So from an individual drive standpoint or an individual load solution standpoint, we'll talk about drive dedicated or broadband filters. Now if you look at this picture, this shows two drives, one on the left that doesn't have a filter in front of it, one on the right that has a broadband or a drive dedicated filter in front of it. So the harmonics coming out of the drive on the left are going to flow back up on the system, and like we've talked about many times, those currents are going to find the path of least impedance. So most of them are going to flow back out in the system and come back to the loads. The one on the right where the filter is, if you notice there's a large 10% reactor that basically blocks the harmonics from leaving the drive that's connected to the bus there, and so they want to flow into the filter. And the harmonics that are coming out of the other drive on the left don't want to come into the filter. So it turns what would basically be a 6-pulse drive into roughly a 12 or 18 pulse system. Now what we'll do is I'll show you what the guts of that type of a filter look like. So let's take a look inside this box. And so if you notice down at the bottom there's your 10% reactor that blocks the harmonics from coming in the filter into hit the other drive or into the filter, and it also blocks the harmonics from coming out. So there's your other reactor up in the top left and your capacitor in the background there on the left that makes up the shunt harmonic filter. All the other contactors and everything in there are for part of our demo, but we also have a contactor to be able to remove the capacitor outside of that, because if you do have a capacitor, what can happen is that capacitor at a very light load will look like power factor correction and maybe raise the voltage. So when that drive dedicated filter doesn't have a load on it, that capacitor acts to raise voltage. Okay, now we're going to take a look at doing a demonstration, and we'll see how this filter actually works. And so now I'm going to set up the drive to run just as a standard 6-pulse drive. And with the standard 6-pulse drive running, we're going to have our typical 5th and 7th, 11th and 13th harmonics. So here's our harmonic spectrum. We'll see our 5th and 7th, 11th and 13th harmonics. Now what we're going to do is I'll go back to the waveform here. And I'll turn on the drive dedicated filter. And you'll see that the waveform basically looks like a nice clean sinusoidal waveform. And we'll look at our harmonic spectrum. And you can see the 5th and 7th harmonics kind of go away. And you're left with what would essentially be your 11th and 13th harmonics. So ultimately what we ended up with was taking a 6-pulse drive, putting a drive dedicated filter or a broadband filter in front of it, and it turns it into what would be essentially a 12 or 18 pulse drive.